Hi everyone, welcome to my channel. My name is Javier Rodriguez. This is Data Analysis Insights. I would like to ask you, if you like the content of this channel, please subscribe. If you like the content of this video, please thumb up. If you like to add any comments, please put in the comments below. Hi everyone, today I would like to show you the data lifecycle from creation to consumption from an on-premises perspective. First of all, I would like to dive into basic concepts such as dimensional modeling, business processes, and what is the grain of the data warehouse. In this process, we can find several layers or stages. The first one is the operational layer. In this layer, it includes data sources. The second one is the data extraction layer, basically the ETL. The following one is the staging layer or processing layer. The following one is the storage layer, basically the data warehouse. Once we have the data warehouse in place, we are going to create the analytic layer. Basically, it's being used for data delivery. And the presentation layer, which is the data consumption layer. Basically, this is the data flow architecture. So we can have different data sources. After that, we are going to, with the ETL, we are going to populate the data in the right manner in the staging areas. Once we have the DIM tables and fact table in staging, we are going to move this data, these tables into a data warehouse, or depending on the process, if we are following Kimball process or Imon process, we are going to have a full complete data warehouse from Imon perspective, or we are going to have a small data mart, and once we have all data marts, we are going to create a data warehouse following the Kimball process. After that, we are going to populate with views the different tabular cubes, and once we have the tabular cubes in place, we are going to create different Power BI reports connecting live to these tabular cubes. Basically, this is the data flow architecture. Now we are going to dive into basic concepts. Basic concepts, business processes. Business processes are the operational activities performed by your organization, such as taking an order, processing an insurance claim, registering a student for a class, or snapshotting every account each month. Business process events generate or capture performance metrics that translate into facts in a fact table. Most of the fact table focus on the results of a single business process. Choosing the process is important because it defines the specific design target and allows the grain, dimensions, and facts to be declared. Basically, the business process is a register of the operational activities. This is important for the business because we are going to have one business process allocated to one fact table. Well, there are some exceptions. For example, in finance, we can have one fact table to record the actual values, and we can have another fact table such as budget, which is slicing by the actuals and targets. So this is the only business process that I have at the top of my head, which we can have more than one fact table. It's important because each business process corresponds to a row in the enterprise data warehouse bus matrix. Basically, a bus matrix, when we are designing the data warehouse, it has many rows, and each row is a business process, and the columns are the different dimension tables. We have only one the dimension table, which cut every single business process, which is the team date table. Following with the slide, the 4 key decisions made during the design of a dimensional model include select the business process, which is key, declare the grain of the fact table, which is key 2, identify the different dimensions in the business, obviously identify the different facts. Basic concepts, dimensional modeling. Before launching a dimensional modeling effort, the team needs to understand the needs of the business as well as the realities of the underlying source data. You uncover the requirements via a session with business representatives to understand their objectives based on key performance indicators, compelling business issues, decision-making processes, and supporting analytic needs. At the same time, the data realities are uncovered by meeting with source system experts and doing high-level data profiling to assess data feasibilities. Dimensional models should be designed in collaboration with subject matter experts and data governance representatives from the business. The data modeler is in charge, but the model should unfold via a series of highly interactive workshops with a business representative. These workshops provide another opportunity to flesh out the requirements with the business. Dimensional models should not be designed in isolation by folks who don't fully understand the business and their needs. Collaboration is critical. Well, basically what I try to say with this slide is for creating a data warehouse, which is the core of the business intelligence process, is we need to discuss with the different heads of the departments to gather the information, the KPI scores, which should be shown in the reporting system. We need to be agreed and conform the information across the business. This is one of the key things of this process. Now we have defined what is a business process. We have defined the structure of the data modeling. It's time to define what is the grain of the data warehouse. The grain establishes exactly what a single fact table row represents. The grain declaration becomes a binding contract on the design. This is key. So one of the worst things we have in data warehousing is breaking the grain. For example, if we have the data warehouse defined by dates, so all our fact tables are allocated to dates. At some point, because of the requirements, we need to define the different fact tables based on hours. For example, the brain has broken. So because we are going to have in one day many hours, so the lowest detail level of the different fact table has changed, and this is really bad. It's really bad because all our reporting system is being affected. So we need to recreate the different fact tables again with the new grain. On the other hand, if we have defined the grain based by dates and we need to aggregate data based on weeks, because the lowest level of the data is the date, the aggregation doesn't break the grain. Just only aggregating the different facts, we are going to have the required result. And this is really important. The grain must be declared before choosing dimension or facts because every candidate dimension or fact must be consistent with the grain. This consistency enforces a uniformity on all our dimensional designs that is critical to BI applications, performance, and ease of use. It's what I said before. So breaking the grain of the data warehouse, in future, our reporting system won't have any meaning. Atomic grain refers the lowest level at which data is captured by given a business process. We strongly encourage to start by focusing on atomic grain data because it withstands the assault of unpredictable user queries. Roller-up summary grains are important to performance tuning, but they presuppose business common questions. Each proposed fact table grains result in separate physical table. Different grains must not be mixed in the same fact table. For example, if we have a fact table sales by date, and we need to create sales by hour, we need to create another fact table. This is absolutely critical. Define previously, when we're starting to design the data warehouse, define the grain. Therefore, it's crucial to define properly the grain, because it will save a lot of time and money in future. Once we have our data warehouse in place, it will be an excellent tool for reporting, and we will have a unique source of truth in the business. Well, we have seen basic concepts. Now it's time to dive into the data flow. Let's go for it. Here we have the data flow architecture, and we have here the different layers of the architecture. Let's dive into the operational layer. Data sources. Operational layer. A transactional database is a system designed to manage and facilitate transactions, which are sequences of operations treated as a single unit of work. This database ensures data integrity and consistency, though acid, atomicity, consistency, isolation, and durability properties, making them essential for applications requiring reliable and accurate data handling, such as banking, e-commerce, and inventory management. So basically, the transactional database records our daily activity. That's it. The transactional systems are databases that record a company's daily transaction. The three major transactional databases include CRM, Customer Relationship Management, HRM, Human Resources Management, and ERPs, Enterprise Resource Planning. For instance, a sales transaction could be recorded and stored as a piece of data in the CRM database. We can have many more sources in the business, such as SQL Server database, Oracle databases, MongoDB databases, which are non-SQL database, Neo4j, which are graph databases. We can have Excel spreadsheets, SharePoint files. We can have vendors such as Salesforce. We can have many source types. However, transactional systems are not considered for optimal business intelligence. What it means is we have recorded the daily operations, such as sales. So we have records every day. We have many sales. Inside the CRM, we can have the different customers, the sales, the suppliers, the employees. In the human resource management databases, we have all this data. However, this system cannot respond a simple question such as where are most the sales done? With another question is who is the person who sells the most? Question like this cannot be answered by this system. So we need to create another database to analyze data, which are the data warehouse. At this point, we have seen some basic concepts such as dimensional modeling, what are the business processes, and what is the grain of the data warehouse, or the fact tables. We have seen the first layer, which is the operational layer. Because I don't want to overwhelm you with so much information and so much definition, I prefer stop the video here and continue creating new videos for the different stages. If you like this video, please thumb up. It will help me to create new content. Thank you very much for watching.